All right, let's go ahead and continue our discussion of exponents and the different rules that we have. We're specifically going to be talking about integer exponents. Remember, integers are any number that are whole numbers, so no fractions or decimals, and they're either positive or negative or zero. So let's start off with our zero exponent rule. So what our zero exponent rule says is that if we have any number except for zero, so any number a raised to the zero power, we always get 1. And then we're going to say a cannot equal 0, just because 0 to the 0 power is undefined. So let's go ahead and look at some examples, and most of these are going to seem pretty obvious just because we're raising something to the 0 power, and you should always get 1 no matter what, but there are some cases where you raise something to the 0 power and there's other negatives or something going on, so you have to be careful with those. So examples, we're told to evaluate, so that's just kind of another word for simplify, except evaluate is usually just used for when you just have numbers and you're not really combining like terms, but you can kind of interchange both of those. So number 1, 28 to the 0 power. So 28 to the 0 power, I'm going to change that to a slightly bigger 0 just because it looks like a degree symbol. 28 to the 0 power, any number raised to the 0 power is always 1. Number 2, we have negative 16 to the 0 power. So this is one of those negatives where the parentheses makes a difference. So since we're raising that entire number to the 0 power, we still get 1. However, if we had negative 16 to the 0 power without parentheses, the only thing we're raising to the 0 power here is the 16. So remember those order of operation rules. The exponent, think of this like a negative 1 times 16. We do exponents before we multiply. So 16 to the 0 power is 1, and then we want the opposite of that, so we get negative 1. So just notice the difference, parentheses or no parentheses, it's going to make a difference with your signs. And then it's going to be the same thing if we have a variable. So m to the 0 power is still 1. We don't have any negatives messing anything up. This is another one that we have to be careful with. Negative 2p to the 0. So we want to figure out what that 0 exponent is being applied to. So since there's no parentheses, it's only going to go to the number variable directly next to it, which is the p. So we have negative 2 times p to the 0. P to the 0 is 1. So negative 2 times 1 is negative 2. Number 6, 5r in parentheses raised to the 0. Couple ways to think about this one. The fastest way to do this one is just realizing we have some term being raised to the 0 power, and we get 1. Even if we had, let's say we had 24x squared yz cubed, all of this raised to the 0 power is still going to be 1. And the reason for that is that if we think about one of our power rules from last time, if we distribute in the 0, then this is giving us, I'll just write this off to the side here. This is going to give us 5 to the 0, r to the 0. 5 to the 0 is 1, times r to the 0 is 1, and 1 times 1 is still 1. Even if we have all of these being multiplied together, it's still going to be 1 times 1 times 1 times 1. So shortcut is the fastest way of doing it. If you want to distribute, that way totally works too. Let's go ahead and try one more. 14 to the 0 minus 12 to the 0. So for this one, you have to, again, think back to order of operations. We want to do our exponents before we subtract. So 14 to the 0 is 1, minus 12 to the 0 is 1. 1 minus 1 is 0. So just remember order of operations when you're taking a look at these. All right, so now let's take a look at negative exponents. We've already seen positive exponents last time. Now we've seen 0, so all we have left in the integers is the negative numbers. And for negative exponents, what we're going to do is we're going to go through and kind of figure out how mathematicians defined negative exponents, because they had kind of a systematic way of doing it. So let's say we have 2 cubed. So 2 cubed, remember 2 times 2 times 2 is 8. 2 squared is going to give us 4. 2 to the first is just 2. Normally we'll just write that as 2. 2 to the 0, we just saw this is 1, and we can kind of see why that is in a second. We want to know what 2 to the negative first is. So if you see, I'm kind of just going down on the exponents. Well, if we go up, because we're multiplying by another 2 every time, or we're adding an exponent, we're just multiplying each of these by 2. So the opposite of multiplying something by 2 is dividing it by 2. So if we go down the column here, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1, which is why any number raised to the 0 power is 1. And then if I take 1 and divide it by 2 again, 1 divided by 2, or 1 split into 2 equal pieces, is 1/2. So now if I take a look at 2 to the negative second, if I divide that by 2 again, 1/2 split into 2 equal pieces, we get quarters, or 1/4. So then if we take a look at these denominators here, we had 2, 4. Up here we had 2, 4. So our next fraction, 2 to the negative third, is going to be 1/8. So if you notice, we get exactly what we had up here, but it's on the bottom of a fraction. So this is our negative exponent rule. What the negative exponent rule says, if we have some number a raised to the negative n, this is the same thing as doing 1 over a to the positive n. And if we take a look at this one here, 2 to the negative second, if we take this and put 1 over 2 to the positive second, then we get 1/4, which is exactly what we had. So this is a big one. And another way that you might see this written, and this is going to come up when we start simplifying these in a second, if the negative exponent is on the bottom, so 1 over a to the negative n, you don't see this one as much, but it does come up. What we're going to do, kind of like what we did here, we took the a to the negative n, moved it to the bottom, and changed it to a positive exponent. We're going to take this a to the negative n, move it to the top, and make the exponent positive. And so we don't need that 1 on the bottom. Usually we'll be doing these where we have some other terms there, so there might be something left on the bottom. Because this was the only thing in the denominator and we moved it out of the denominator, there's no longer a denominator there. But notice how if we only have something in the denominator, we do have to put 1s on the top, because otherwise we'd have nothing up there, and you can't have a fraction with nothing in the numerator. All right, let's take a look at some examples. And let's go ahead and evaluate again, or simplify these down. So number 1, 4 to the negative third. So just like we just saw, we're going to take the term with the negative exponent, move it to the bottom of a fraction and make the exponent positive. So this becomes 1 over 4 to the positive third. And 4 to the positive third is 64, so we get 1 over 64. Again, if the number is reasonable, so not too large, less than 1,000 usually, but they'll usually say if it's an exponent of 4 or below, something like that, evaluate. So make sure you fully multiply those out, otherwise you'll get the question wrong on my math lab. Number 2, 6 to the negative second. So again, negative exponent, we want to go ahead and make it positive first. So 1 over 6 to the positive second, and 6 squared is 36, so 1 over 36. Okay, these next ones are where it starts to get a little bit trickier. This one we have 1/4, all raised to the negative second. So you might see this done 2 different ways. One thing we can do is flip the fraction and change this to a positive second. I like using the rules that we talked about last time because I think this is a little bit more intuitive and easier to remember. So what we're going to do using our power rules from last time, remember if you have a fraction being raised to an exponent, positive or negative, we can go ahead and distribute that in to both of those terms. So on the top, we're going to have 1 to the negative second. On the bottom, we're going to have 4 to the negative second. And then if we use our negative exponent rules now, remember if it's on the top, it moves to the bottom. And if it's on the bottom, it moves up to the top. And we make those exponents positive. So what I normally like to do, because sometimes you're going to see, and we'll see some in a second, where some of your exponents are positive, some are negative. You won't be moving around all the terms. So I'm going to circle the terms I'm going to move and just kind of point where I'm going to move them. So the one on the top moves to the bottom. The one on the bottom moves up to the top. So now the only one on top is going to be 4 to the positive second. The one on the bottom is going to be 1 to the positive second. Once all of your negative exponents are gone, we can go ahead and start simplifying. So 4 squared is 16. 1 squared is 1. 16 divided by 1 is 16. And let me go ahead and show you the kind of shortcut for this one. I don't recommend this way, but if this makes more sense to you, go for it. And this only works when you have this kind of single fraction being raised to a negative exponent. The shortcut here is anytime you have a fraction raised to a negative exponent, we can flip the fraction, so 4 over 1, and then make the exponent positive. And so if we do that, 4 over 1, simplify inside first. Because we can reduce that down, I'm going to make that 4, and then squared, and 4 squared is 16. So flipped fraction. Make exponent positive. So that's kind of the shortcut. If you want to do it that way, go for it. We could have also gone from this part and then started to distributing that exponent. That's not necessary though, because if you can simplify the fraction on the inside, like we did from 4 over 1 to 4, it kind of gets rid of that extra step there. All right, so let's try another one like that now that we've seen that one. So if you want to try this one by yourself, the shortcut, or the first way we did it, go for it. 2/3 in parentheses to the -2nd. So I'm going to do it the kind of lengthier way, but this way is going to be helpful when we start getting into some other expressions to simplify. So I'm going to distribute in that -2. So we get 2 to the -2nd over 3 to the -2nd. And then any negative exponents need to be moved. So this one will go down, this one will go up. So we get 3 to the +2nd over 2 to the +2nd. 3 squared is 9, over 2 squared is 4. So even if you did this with the shortcut, you should have 9/4. With the shortcut here, I'm going to flip the fraction, make that exponent positive, and unlike the one that we had last time with the 4/1, we do have to go ahead and distribute this. So we get 3 squared over 2 squared, and that gives us the 9/4. So this one is actually the same number of steps. It still took 1, 2, 3, 1, 2, 3. It's just a matter of preference, whatever you guys like better. Okay, number 5, 2 to the -1st plus 5 to the -1st. So for this one, remember we have to evaluate exponents before we add. We can't just add these two terms together, even though they have the same exponent. They don't even have the same base. Even if they did, we still couldn't combine them because we have to do our exponents before we add. So if I were to simplify 2 to the -1st, I'm going to move it to the bottom of its own fraction. So 1 over 2 to the +1st, or just 2, plus I have to do the same thing with this guy. So each of these individual circles I'm going to make into its own individual fractions. So if you have addition or subtraction in between, you can't put them in the same fraction. That kind of splits them up because they're two different terms. So 5 to the -1st is 1 over 5 to the +1st. And then we want to go ahead and combine our fractions. So our LCD is going to be 10. 1/2 is going to become 5/10. 1/5 is going to become 2/10. And if we add those together, we get 7/10. So again, really common mistakes here. Probably the number one mistake is putting them in their own fractions. So make sure the 2 and the 5, if they're separated by addition or subtraction, they have their own fractions. And then remembering to put them into fraction form before you combine is probably the other biggest mistake with this one. All right, number 6, 7m to the -5th. So there isn't a whole lot to simplify with this one because we can't really evaluate any exponents. But the big thing to remember with these is we don't want negative exponents in our answers. It's kind of like when you have a fraction that's not reduced. We don't like that. We don't like negative exponents in our answers either. So if you see them, first thing you want to do is get rid of them. And with this one, we want to identify first what is being raised to the -5th power. Is it the 7 and the m, or just the m? Well, for this one, because there's no parentheses, the base is just the m, so I'm going to circle that, and that has to move down to the bottom of its own fraction. But if you notice, the 7 and the m are being joined by multiplication. So it's not like up here where we had addition and we had to have two separate fractions. Because this is being joined by multiplication, the 7 is just going to stay on the top because we don't have to move it. And the m is going to move down to the bottom. So m to the +5th. So just remember, if there's a single term here, then it's going to stay as a single term here. just with division instead of multiplication. If we had 2 terms to start, we're going to have 2 terms when we move our, or when we get rid of our negative exponents. So your number of terms just has to stay the same. So always double checking that you have the same number of terms that you started with is really important. Okay, number 7, 1 over z to the negative 6. We've already seen one kind of like this. First thing we want to do is get rid of our negative exponent on the z by moving it up top. The 1 up here isn't going to change anything. So technically, if we move it up, we have 1 z to the negative 6. Nothing in the denominator, but 1 times something is still just that number. So we still have, oh, I'm sorry, that should be a positive 6. If we multiply something by 1, it doesn't change it, so we just have z to the 6. Number 8. P squared q to the negative 5th. This one's similar to number 6 in for the fact that q is being raised to the negative 5th, but p has a positive exponent. So that p is going to stay on top, this q is going to move down to the bottom. So p on the top of the fraction, and on the bottom, q to the positive 5th. And because they're different variables, we can't combine them. Let's go ahead and do number 9. So x to the negative 3rd over y to the negative 2nd. This is another one like we saw over here. So since they're both negative exponents, the one on the top moves down, the one on the bottom moves up. So one on top now is y to the positive 2nd, and the one on the bottom is the x to the positive 3rd. And then just 2 more examples here. Number 10, 4h to the negative 5th over m to the negative 2nd k. So for this one, we want to figure out what is being raised to the negative exponent because we want to get rid of those negative exponents first. On the top, it's just the h, so that one has to move down. And on the bottom, it's just the m, so that one's going to move up. So whatever is on top and on bottom without a negative exponent is going to stay there. So I'm going to put the 4 up top and the k down on the bottom, just so we don't forget them. And this m is moving up, so m squared. And this h is moving down, so h to the positive 5th. And it technically doesn't matter which order you put this in. If you wanted to put 4m squared over h to the 5th k, that's also perfectly fine as long as you have the correct variables raised to the correct exponent. So make sure the 5 is with the h, and the k shouldn't have an exponent with it. Okay, and let's go ahead and try one more. I'm going to squeeze it in here. This last one is 3m over p, all raised to the negative 2nd. All right, so for this one, I'm going to go ahead and this is one like this where you have a fraction raised to a negative exponent, so you can flip it and make it positive or distribute first. Either way, we're going to be distributing, so I'll just distribute first. So we're going to distribute this to every single part of the term. So the 3, the m, and the p. So 3 to the negative 2nd, m to the negative 2nd, over p to the negative 2nd. One thing you might see on my math lab if you get help with these is that when they distribute it to the top, they might leave it as 3m in parentheses to the negative 2nd, and then do this in an extra step. I just like to avoid the extra step and distribute to every single part at once. And now we have to get rid of our negative exponents. So let's move all of our terms around. This term has to go down, the 3 has to go down, and the p has to go up. So now the only thing on the top is the p squared. The things on the bottom, we have a 3 squared and an m squared. And the only one that we can simplify is the 3 squared. So we have p squared over 9m squared. All right, now let's go ahead and look at our last exponent rule here. This is our quotient rule. And before I actually write this one out, I'm going to go ahead and show you kind of why we do what we do here. So let's say we have 5 to the 4th over 5 to the 3rd. So if I were to write all of these out, we have 5 times 5 times 5 times 5 on the top, and 5 times 5 times 5 on the bottom. And now I can cancel things out. So we'll cancel out these 5s, and we're left with a single 5 to the 1st power on the top. And so if we look at the relationship between the exponents that we started with and what we ended with, we subtracted our exponents. What I like to do a lot of the time, especially when you get into Math 96, if you're going that direction, I like to think of it as canceling them out because it's going to make it a lot easier when we have more, let's say 5s on the bottom than on the top. We can kind of avoid negative exponents. So I'm probably going to refer to it more in that sense than subtracting them, but subtracting them is definitely a good way to do this. So let's go ahead and write out our quotient rule. A to the m, so some term raised to the m power, over the same term raised to the n power. We're going to keep the same base and subtract our exponents. And notice how it's top minus bottom. That's really important. If we had subtracted bottom minus top, it would give us a -1, which is not what we want. So make sure you're always doing it in the correct direction. All right, let's go ahead and look at some examples. So let's write these out first. And let's go ahead and simplify. Number 1, 5 to the 11th over 5 to the 8th. So again, for this one, let's go ahead and use our quotient rule. So if we subtract 11 minus 8, we get 3. Keep the same base, and we get 5 cubed. 5 cubed is 125. So ones like these, pretty straightforward. Just remember division, subtract your exponents. And then the way to remember this is, you remember the product rule. When you're multiplying, you add the exponents. When you're dividing, you subtract. So just remember those kind of opposite pairs going together. Multiplication with addition, the opposite of both of those, division and subtraction. All right, so number 2, let's go ahead and try 4 to the 7th over 4 to the 10th. So now I'm going to show you 2 different ways for this one. One way I find a little bit nicer, especially when you get to ones where you have multiple parts to a term, so numbers and variables on the top and bottom. And we'll see more of that later. For this one, if we use our quotient rule, we're going to take the top minus the bottom, so keep the 4. 7 minus 10 is -3. We don't like negative exponents, so we want to go ahead and get rid of this by moving it to the bottom. So 1 over 4 to the positive third, and 4 to the third is 64, so 1 over 64. The other way that I like to think about this, and this is kind of like what we were doing up here when we looked at this example, think about how many 5s you can cancel out. In this one, we have 7 4s on top, 10 on the bottom. So we can go ahead and cancel out 7 of them, and we'll be left with 3 on the bottom. The way to do this one is imagine writing out all the 4s. And you'll get the hang of this the more you do it. But if you think about how many you're canceling out, we have nothing left on the top, but we still have to put a 1. And now we have 4 cubed on the bottom. So we're jumping straight to the step and avoiding negative exponents, which I really like, and still getting the same answer. So again, if you have one way that you prefer over the other, go for it. I'll show you some examples here in a second where it's going to be more helpful that you do the second way, but either way is going to work. Okay, let's go ahead and try, let's do 6 to the negative 5th over 6 to the negative 2nd. So this is one of those where you can do the quotient rule first or get rid of your negative exponents first. I don't like using the quotient rule first here because if we were to subtract -5 minus -2, we're dealing with all these negatives and I just don't really like working with all those. So what I'm going to do is get rid of the negative exponents first. So I'm going to move the one on the top to the bottom, move the one on the bottom to the top. So now we have 6 to the positive 2nd over 6 to the positive 5th. And now we can subtract, so we can use our quotient rule like we did here, or we can cancel the terms out. I'm going to go ahead and cancel. So 6 to the positive 2nd and 6 to the 5th. So we have 2 up here, 5 down here. So we can get rid of the 2 on top. And if we get rid of 2 on the bottom, we're left with 3. So on top we have a 1, on the bottom we have 6 cubed. And then 6 cubed is going to give us 216. So 1 over 216. And again, just so you can see it, if we did this the other way and subtracted, 2 minus 5 is -3. So we'd have 6 to the negative 3rd, which would take us back to this step here. So again, personal preference, whichever one you like better. Okay, number 4, 8 to the 4th, m to the 9th, over 8 to the 5th, m to the 10th. So these are the ones where I find it really helpful if you think about canceling out some of these variables. And I'm just going to change this one so it's m to the 10th on the top and m to the 9th on the bottom. So if we were to go ahead and use our quotient rule, 4 minus 5 is -1, so 8 to the negative 1st. M to the 10th minus 9 is 1, so m to the 1st. And then we have to take this 8, move it down to the bottom, so the m stays on top, and then we have 8 to the 1st on the bottom. This is one way that totally works. Just make sure that none of the terms that we subtracted go on the bottom of a fraction straight away. Those should all be on the top. So it gets a little confusing if I had another term here to figure out what goes where, which is why I like canceling things out. Because if we would have just canceled things out, let me go ahead and rewrite this one. If we look at the 8s, we have 4 on top, 5 on the bottom. You can always cancel out your lowest exponent. So we can get rid of 4 of them, which means we're left with 1 on the bottom. We can get rid of 9 m's, which means we're left with 1 on the top. So on the top, we have m to the first, which is m, and on the bottom, we're left with 8 to the first, or just 8. So again, a lot faster doing it this way. Definitely prefer it this way. And let's go ahead and look at one more. Number 5. X plus y in parentheses to the negative third over x plus y in parentheses to the negative fourth. All right, so again, I'm going to get rid of negative exponents first. So I'll move this on the bottom up to the top and this on the top down to the bottom. So on the top, we have x plus y to the positive fourth. And on the bottom, we have x plus y to the positive third. And even though we have stuff in parentheses here and some addition, we still have the same base being raised to exponents. So we can use our quotient rule or think about canceling things out. We have 3x plus y's on the bottom, 4x plus y's on the top. So we can get rid of 3 on the top and bottom. So we're left with 1 x plus y on top, which is just x plus y. Okay, now let's go ahead and try a few examples where we combine our rules together. So we want to remember our rules from last section. Number 1, 3 to the fourth in parentheses squared over 3 cubed. So with this one, remember, what do we do with these exponents when we have an exponent raised to another exponent? Well, they're separated by a parenthesis, so we multiply. So on the top, we get 3 to the 8th. On the bottom, we have 3 cubed. And now either think of this as canceling out 3's or using the quotient rule and subtracting your exponents. I'm going to cancel them out, so I'll cancel out 3 3's on the bottom, 3 3's from the top, so we're left with 3 to the 5th. And 3 to the 5th isn't too bad, actually. 3 to the 5th is 243. Number 2, let's go ahead and do 4t in parentheses to the 5th. And then 4t in parentheses to the negative third. So again, there's a couple ways of doing this. There isn't, between these two ways, neither one is right or wrong. They're just two different ways of thinking about this. One way is to get rid of the negative exponent first. The other way is to use our product rule and add the exponents. I tend to avoid any work or addition or subtraction with negative exponents just because I feel like it messes a lot of people up. Some people do, if you were subtracting, just subtracting or adding with the negatives wrong. So what I like to do is always just get rid of those negative exponents first. So I'm going to move it to the bottom of its own fraction. So the 4t to the 5th on the top is going to stay. 4t to the 3rd is now on the bottom. We could distribute right now, which would be good if these weren't the same term, but because we have a 4t on the top and the bottom, I'm going to go ahead and combine them by canceling things out. So we have 3 4t's on the bottom, 5 of them on top, so we can cancel out 3 of them, and we're left with 2 on the top. So we're left with 4t, still in parentheses, squared. And now I'll distribute. Remember, you want to keep simplifying until you can't do anything else. So we get 4 squared, t squared. 4 squared is 16. T squared is just t squared. If we would have used our product rule, we would have added the exponents, and 5 plus -3 gives us 2, and this would have taken us straight to this step, but it's just a matter of preference. I will always get rid of negative exponents first. If you want to use the product rule and go this way, you can do that too. Number 3, 5 over 2z to the 4th, all in parentheses to the -3rd. All right, so this is another one where we can either flip the fraction and make it positive, or distribute first. I'm going to stick with distributing first to every single part of our terms. So 5 to the -3rd over 2 to the -3rd, and then z to the 4th to the -3rd. So be careful with that exponent. We're going to multiply those in a second, so if you wanted to do it right then, you could. I'm going to leave the negative exponents here until we have our parentheses completely gone. So 5 to the -3rd over 2 to the -3rd, multiply these, and we get z to the -12th. And now let's go ahead and get rid of our negative exponents. So on the top, we'll move this down. The terms on the bottom have to move up to the top because they both have negative exponents. So on the top now we have 2 to the +3rd, z to the +12th, over 5 to the +3rd. And then let's go ahead and just simplify our numbers. 2 cubed is 8, z to the 12th, over 5 cubed, which is 125. And there's no simplifying we can do for either of those. All right, let's go ahead and do one last problem here. These exponent rule questions can seem really tricky at first, and there's kind of a lot going on. But the more you practice them, the more you'll get those rules down and kind of instinctively multiply or add or subtract your exponents. It's just a matter of practice. All right, so on the top of this one in parentheses, we have 6y to the -4th. That's being raised to the -2nd. And on the bottom, we have 7 to the -1st, z to the 5th. So this one's kind of a big mix of some different rules here. First thing to realize is that the parentheses are only around the top of the fraction. So when we distribute this exponent, it's only going to the top. So I'm going to focus on just getting rid of parentheses first, and then we'll deal with our negative exponents in a second. So I'm going to distribute this, and we get 6 to the -2nd, y to the, now y to the -4th raised to the -2nd, we want to multiply. So we get y to the 8th. Just so I can avoid writing a step there, I'm going to write that just off to the side. The bottom stays the same because we're not distributing there. So 7 to the -1st, z to the 5th. And now we want to go ahead and get rid of our negative exponents. So the 6 to the -2nd has to move down. The 7 to the -1st has to go up, but the y and the z are going to stay there. So I'm going to put y to the 8th, z to the 5th on the bottom. And now on the top, we're going to have 7 to the 1st. On the bottom, we have 6 to the +2nd. And now finally, just simplifying our numbers, 7 to the 1st is 7, y to the 8th. And on the bottom, 6 squared is 36, z to the 5th. And that is all of our rules combined. We have our power rules, product rules, and those are all of our exponent rules. So now we're going to use some of these to talk about scientific notation, which is a pretty short section. Just going to be doing a little bit of work with numbers and scientific notation, which is going to be helpful for any of your science classes.